All right, today we're going to continue talking about how to solve linear systems of equations by learning the last method we need to know, solving by elimination. It's also called linear combination, and we'll get into why it might be called that in just a second. So, elimination is just a method of solving a system by eliminating or canceling out one of the variables, by adding or subtracting the two equations. So essentially what you're going to do is you're going to take the two equations in the system. So in this case, we have 4x minus 2y equals 12, and x plus 2y equals 8. These are the two systems, or two equations in my system. We are going to combine these two using addition or subtraction in hopes of canceling out one of my variables. So step one says, add or subtract the two equations to cancel one of the variables, and then solve. So sometimes you'll need to multiply one of the equations first before you're able to cancel one of the variables. But what you're looking for is you're trying to assess your system to see if one of your variables creates a zero pair with the other equation. So looking at these two equations, do you see a zero pair with some of your variables? Raise your hand if you see a zero pair that would combine to cancel out your variables. Krish? 2y and negative 2y. So these two, if you were to add them together, they would cancel out completely. And that's the goal. You're looking to see if you can add the two equations together and cancel our variable out. Just one of the variables is the goal. Because when you cancel out one of your two variables, you only have one type of variable left, and you can actually solve to see what the value of the other variable is. Note, sometimes you'll need to multiply first, again, but in this case, things are already set up perfectly to be able to solve right away. So, let's go ahead and combine these two as they are. This method is generally going to work best if your two equations are in the same form. Most often, it's going to be easiest if they're in standard form. I'd say just on average, graphing is best if you have slope-intercept or y equals mx plus b equations, because you can graph those in Desmos and solve from there. Substitution is going to be best if you have one in standard form and the other has an equation isolated. So if I have y equals mx plus b and a standard form, or if I have x equals some y plus a number, that would also be another good situation to use substitution because you already have one variable isolated and the other equation is not easily graphable. So then you could just substitute and solve. Elimination is going to be best if your two equations are both in standard form. And the reason why I say both in standard form is because you want them in the same form so you can sort of sandwich them together. But if they're both in y equals mx plus b form, well, you might as well just graph them at that point, and that's a lot easier. So these are the three methods we've essentially learned at this point. They all have different uses, but you kind of need to know them all depending on the situation. Remember that a lot of times you don't have all day to take these tests. So finding the quickest and easiest method is going to save you time, so you actually have enough time to finish. All right, all that aside, let's go ahead and solve these. When you go to solve these, or like eliminate and combine your two equations, I highly, highly recommend that your zero pair are opposites. So positive 2y and negative 2y. You can technically, say for example, this was positive 2y also, and the other one was also positive 2y. You can technically subtract and then solve from there, But I recommend that if you're in this situation, instead, you just multiply everything by -1 to flip the signs, and then combine or add. Don't worry about subtraction, because I find that subtraction often causes you to make mistakes. So I recommend that you try to just add by setting everything, or setting your term that you're trying to cancel out to be an actual zero pair. So anyway, let's actually do the process now. So we're going to add these two equations together. What is 4x plus x? 5x. What's going to happen with my y's? They're going to cancel out. What's 12 plus 8? 20. And now what's my last step to solve? Divide by 5. So x is equal to 4. And there it is. Step 1's done. We found what the actual x value is that satisfies this system. So remember that if I plug x in to either of these two equations, we should get the same y value. That's the definition of a solution to a system, is when you plug in an x value, the y value will be the same for both, if that's the true solution. So we found our x value. That's half of our answer. We are halfway done solving this system of equations. Now we have step 2, and at this point, it's pretty much the same as substitution. The only thing that's really different is step 1, where you eliminate first, and then in substitution, step 1, you substitute first. But after that, after you find one of your two values, in this case we found x, you're just going to substitute that into one of the two equations. So you can pick either of these equations, but one will possibly or most often be easier than the other. So this bottom equation, the second one, x plus 2y equals 8, is going to be easier to solve for y than the other. So I'm going to write 4, because I substituted x for 4, plus 2y equals 8. What's my first step going to be? We're going to subtract 4 on both sides. So I'm going to do -4, -4. This is going to cancel, and I'm left with 2y equals 4. What's my next step going to be? Divide both sides by 2. And I'm going to divide both sides by 2. The 2 cancels. The coefficient of y cancels, and I'm left with y equals 2. So now we have the second part of my solution when x is 4, y is 2 for both of these equations. And you can see that if you actually go and plug these values into both equations, you'll get the same answer. If I plug it into the bottom one, 4 plus 2 times 2 is 4, so 4 plus 4 equals 8. Then 4 times 4 is 16, minus 2 times 2 is 4. 16 minus 4 does equal 12. So both equations are satisfied by this ordered pair, 4, 2. Any questions about this method? All right, we're going to look at a few examples, but before we look at a few examples, never mind. We're going to look at the examples. Let's look at the examples. I'm going to flip the page. Anybody need another second to write this? All right, I'm going to give you all a second to write this. Any questions before? All right, I'm going to go ahead and move on. Perfect. Flip the page. We're going to do some examples on this page. Okay, just the very next page, flip it. I'm going to do this example for you or with you. So, take a look at the first example. Do you see any zero pairs on that first example? No. So what do you need to do to one of these equations? multiply one of these equations. Raise your hand if you see a multiplication I can do to create a zero pair. Anna? Yes, perfect. So if I multiply the top equation by -2, what's going to happen? Let's do that. So remember, when you multiply an equation, every single term inside the equation needs to be multiplied. Not just the thing you're trying to create a zero pair with, but every single term, so you can keep the equation balanced. So I'm going to multiply the first term by -2. I get -10x. I'm going to multiply the second term by -2. I get -2y. I'm going to multiply the third term by -2. I get equals -18. And now we have an equation where if I set it up on top of the other equation, you can see that they would cancel one of the variables if combined. If I combine these two equations together, one of our variables will cancel. So 10x is the one. And I can cancel, you did say it, and I confirmed it. So 10x cancels, and now I'm left with -2y minus 7y is -9y, and -18 minus 18 it's -36. You had it right. So it is -36. So now what's the last step to find the y value? Divide by -9. Yes, divide by -9. We're going to divide by -9. The -9 will cancel, and I'm left with y equals 4. Wow, that was pretty quick. So now, how do I find the x value once we find the y value? Plug it in. So let's plug that y value in to here. I'm going to choose the top equation because it's generally easier. The numbers are smaller. So in my opinion, it's going to make the problem easier. Plugging in 4 for y. First step. Eliminate the parentheses, sure. There's no thing to distribute, so I can just eliminate the parentheses. Now we're going to do what to that plus 4? It's a 4, but I kind of like curved. I didn't pick up my pen. So it's parentheses 4, close parentheses. There we go. This time we're going to subtract 4 on both sides. Not add 4. We have to do the inverse operation. So I'm going to subtract 4 on both sides. And I get 5x equals 5, which, if you then divide by 5, the coefficient in front of x cancels, and I get x equals 1. So raise your hand if now you can put that together and tell me the answer to the question, Bailey. 1, 4. And what does that mean? What does the ordered pair solution mean for the system? Giselle? It's where they intersect. Could somebody else describe another meaning of that ordered pair solution? Anna? Okay, no problem. So this ordered pair is where they intersect if you graph them. Also, it's the place, or it's if I plug that point into both equations. So if I plug in 1 for x and 4 for y into both equations, they will both be true or satisfied. Yes. Okay. So just real quick, we'll look at the top one. I'm not going to go through all of it, but if I plug in 1 for x, 5 times 1 is 5, and 5 plus 4 is 9. So that's right. The other one, I said I wasn't going to do it, but I can't help myself. 10 times 1 is 10, minus 7 times 4 is 28. So 10 minus 28 does equal negative 18. So that is my solution because when I plug that point into both equations, they are both satisfied. Okay, go ahead. Let's just go through this one together because the one on the back of the next page I want to look at real quick. So, can these cancel as they are? Yes. So, you don't have to solve for x. You don't have to solve for y. You can cancel one. You can cancel the other. It does not matter. I'm going to cancel these 4x's. I get 6y equals negative 36. Now, to find the y value, I'm going to divide both sides by 6. And I get y equals negative 6. And there's the y value of my answer. Now, to find the x value, we just substitute. I'm going to substitute into the top equation because the numbers are smaller, which make them easier to deal with most often. For x minus 2 times 6, I get negative 4x plus 12 equals negative 12. Now what step do I need to do?
Plus or minus 12?
Minus 12 on both sides. So I'm going to subtract 12 on both sides. I get negative 4x, and a negative minus a negative is going to become more negative. Negative 24. And now I'm going to divide both sides by negative 4. You get x equals positive 6. So my answer is 6, 6. Okay, take
This is actually
Yeah, I feel like
6, negative 6. Any
Any
questions about this? I highly recommend you guys write the next 2 examples. They're important examples to really remind you about some things that we've covered.
Do we have homework today?
You do.
I actually like doing it.
Perfect.
Am I doing it better?
Hannah,
Is the homework going to be great?
I don't know. I haven't decided that yet. But there's a very clear pattern to the graded homework. Maybe you'll figure it out. Whether or not homework is graded is there's a pattern. Okay, flipping to the next page. All right, here we go. So, are these two ready to cancel? Raise your hand if you see the multiplication that I can perform to cancel one of the variables. Seth? Times positive 2 on the bottom. So I get 4x minus 8y equals 12 minus 4x plus 8y equals negative 12. So, everybody go ahead, perform the elimination on the equations I created on the right.
You want me to do the whole thing?
Just eliminate.
Can I only eliminate one?
Just add them together. Just combine. Just combine. As they are, Matthias, combine them.
0 is equal to negative 12.
What?
So what do I get? 4x minus x, or 4x is 0.
This is stupid.
Negative 8 plus 8y is equal to 0. And 12 minus 12 is equal to 0. 0 equals 0, which is true. And if this were an equation, the value of that variable, if this were an equation with only one variable, the value of that variable could take on all real numbers, take on the value of all real numbers, but we're talking about a system of equations. We're not just looking for one number when we talk about our equation. We're looking for an ordered pair when we're talking about the solution to our equation. So how do we describe the number of solutions there are? There are infinitely many solutions. So if it's a system of equations, you need to call it infinitely many solutions. If it's an equation like 3x plus 4 equals 3x plus 4, then you can say the value of x is all real numbers. But we're not talking about an equation like that. We're talking about a system of equation where we're looking for ordered pair solutions. Caitlin?
I was gonna ask you if it can ever be all real numbers.
Oh, for this?
Yeah.
Yeah, okay. So it's not quite all real numbers. It's similar. These are similar ideas, basically saying that there's unlimited solutions. But we call them different things because this isn't just one number. So my solution isn't all real numbers. If my first solution, let's just say, is 1, 1, 1, 2 would not be a solution because when x is 1, my y is 2 or 1 also. My y can't be the two different things for the same x. It wouldn't be a function. It would be possible, exactly. And maybe 3, 3. And that goes on infinitely. But you can't just combine any random numbers. They have to be ordered pairs that actually satisfy the solution or the inequality or the equation. So there are infinitely many of them, but they can't just be anything. Whereas with an equation here, it could just be anything. All right. Any questions about that one? Last one. Raise your hand if you see any zero pairs. Okay, then raise your hand if you see a multiplication that we can do to cancel one of these equations. Perfect. Multiply the top one by -2. We get -6x minus 4y equals -20. 6x plus 4y equals 50. And Giselle, ahead of us, canceled her two variables because they both happened to cancel out and got 0 plus 0 equals 30. Is that true? No. So therefore, no solution. Any questions about that one?